Okay, and welcome again to this video. This is going to be your example problems on weak acids and weak bases. So again, we're going to be using the formulas that are up there at the top on this. So let's just go ahead and read our problem and get started. So the very first thing that it tells us is that the pKa of hypochlorous acid, which is this formula, is 7.54. And then it wants to know what is going to be the pH of the solution. So again, remember that we have this hypochlorous acid that has been added to water, and it's only going to partially ionize. So you have water in there and you have this acid, and it ended up with a 0.1 molarity, and we need to find its pH. Okay, so a couple of things that we're going to need to do. One, if you notice in the problem, it says the pKa is. And so let's look at our formulas, and we have that the pKa is going to be the negative log of the equilibrium constant for our acid. We got another formula over here that says, now to find that Ka, it is going to be your hydronium ion time your conjugate base over your molarity of your acid that you started with. And so those are the things that we're going to need to do. Now, anytime we do a weak acid or a weak base that we did not have to do with our strong acid and a strong base, is we must write it into its ion. So that's always going to be the first thing that we do. So in this case, we have HClO. And since it is partially ionized, it is going to be a reversible reaction, and that will break into our hydrogen and our chlorate. And again, one of the things that is true about our acids versus some of our other things that we do is these will be one-to-one. So we're not going to have to worry about that piece of it. Okay, the next thing that we're going to look at is we know that our molarity of our acid is going to be 0.100. There's our molarity. And so this is where our Rice table comes in, because what we need to do is we're going to need to figure out what the molarity of our hydronium ion is, which is just shortened to our H+, and we're going to need to find the conjugate, which is the ClO3 or ClO. So we're going to need to find the molarity of both of those. To start with, again, just like what we've done before, we have all the acid. We have none of it dissociated yet, so those are zeros. And now we're going to subtract and add. Okay, and our acid is a liquid on there, or yes, a solution. So we're going to be using it in our formula. So let's just complete our table. X and X. Okay. Now, earlier on, if you'll remember on the previous slide, I told you that we could, in fact, just use this as the hydronium ion squared. Well, if you'll see, this is where that's coming at right here. We've got the two X's. So when I put that into my formula for my Ka, I am going to have my hydronium is X and my conjugate is X, and then it is over my concentration of my acid, which is 0.100 minus X. So this should be very familiar to you, nothing new for the most part on this. Now, a couple of things. Just like we did in the last chapter with our equilibrium, if our what was I looking at here? Oh, if our if our Ka value is really, really small, then remember we could use our 5% rule. Now the question is, can I find my Ka value? So now that's another piece of it. Because up here, I know that my pKa is a negative log of my Ka, and they tell us that the pKa is 7.54. So we know that number. If you've done your problems off of your last set with your pHs, then you know in order to solve our log problem, then we do 10 to the negative pH, normally, in this case pKa, and so I'm going to just run that in my calculator, and that's going to give me 2.88 times 10 to the negative 8 as my molarity. Now, let's go back to where we were at. I just said if the Ka was, remember we used the 10 to the negative 5. If it is less than that, we can eliminate and use our 5% rule. Well, it's 10 to the negative 8. And so we can, in fact, just ignore that minus x. And so we have that our Ka value is going to equal our x squared over 0.100. And you guys should know how to do it. Multiply by your 0.1 to both sides, square root, and get your x value. So I'm going to skip a couple of steps there because I think you guys can handle that math. Let me check my answer and see what that ended up being. So it is 5.37. And you guys always double check my numbers. You should know that by now. To the negative 5. So that is my x value. And remember, now back to where we were at, to find my pH, it is the negative log of my hydronium. Well, that is, right here, my x value. So my pH is going to be the negative log of that 5.37 times 10 to the negative 5. And I'm running out of room here. So the pH ends up being 4.270. Okay, double check my numbers again. Now, guys, when you're doing this, of course, they're going to give you, sometimes they'll give you the Ka. In this case, they gave us the pKa. But generally speaking, if you have a weak acid, you should probably do the Rice table, or again, remember that your formula up here is generally going to be x squared over your concentration. Now, that's if you don't know one of those values. You know, if you don't know your hydronium ion or you don't know your conjugate base, one or the other. Okay? So, that is example 1.